So before we get going, since we're doing trig, let's write down our trig reference sheet. And we've got triangle that looks like this, horizontal, vertical, hypotenuse. We've developed all of our trig functions, the 6 main trig functions. So sine of theta, y over r, cosine of theta, x over r, and tangent of theta, y over x. The other three I don't want to write. They are the reciprocal identities. So hopefully you're starting to get the hang of which one's associated with which. And then the other thing we've been talking about are these two key triangles, or two reference triangles, as I call them. One of them's a 45, 45, 90, and the other one's a 30, 60, 90. Short side 1, long side 2. Other side is root 3. So that's going to be our sheet. We'll have some more things that we want to add on to it today. Before we get to that, let's talk about what a reference angle is. So for a given angle, theta, the reference angle is the angle between 0 to 90 degrees, or 0 to pi over 2 radians, that the terminal side of theta makes with either the positive or negative x-axis. So what do we mean by this? We mean if we have an angle, and I want to compute ultimately the trig ratios of this angle. And so if the angle is in, say, the second quadrant, well, the ratios of the sides are determined by a triangle that is made with the negative x-axis in this case. So even though the actual angle is theta, our reference angle is just whatever that positive angle would be for alpha. And that holds no matter where the angle ends up. So even if the angle ends up in the third quadrant, in which case the entire thing would be an angle, theta, but the reference angle is just going to be this part here. So let's see some examples of this, and I'll give you some pointers and tips of how to work through a lot of these. So let's say we want to evaluate sine of 5 pi over 4. Our first step is to determine the reference angle. And the way we're going to first do it is just by counting in fractions of pi. So, namely, what do we have? If you look at our angle, well, it's a fraction times pi, 5/4 times pi, or we often read it 5 pi over 4. And so what we want to do is essentially count in portions of pi over 4. And more so, we want to keep track of a couple of key angles, namely pi, and pi is 4 pi over 4, and 2 pi, which we can write as 8 pi over 4. We want to write those in such ways that the denominators match. And the reason I'm writing these two angles to begin with is this is the negative x-axis, and then this guy is the positive x-axis. Because our reference angles can be made with either side. So the absolute angle is always measured from the positive x-axis. But when we're determining the reference angle, we really are just looking at the x-axis in total, whether the negative or positive side, and that's going to dictate the reference angle. So what we want to do is determine which side of the x-axis is closest, namely, which number. So we were given 5 pi over 4 is our angle. So which one is that closer to? Closer to 4 pi over 2, or 4 pi over 4. And so what we're going to do is write our angle is 5 pi over 4, and how do we get to 5 pi over 4? That is 4 pi over 4, but that's smaller, so we need to go one more. And this is what determines the reference angle. So step 2 is going to be determine the quadrant. So we had 4 pi over 4, which is pi. So that means we got to go halfway around. But then we need to keep going one more pi over 4. So we'll go to here. So this whole angle is 5 pi over 4. And then as we can see, if we were to draw the sides of this triangle now, the reference angle is this angle here, pi over 4. Step 3 is to fill in the side lengths. And step 4 is to mind the plus and minus signs and evaluate. And there's two different ways we can do this, so I'll show you both. So when we fill in the side lengths, we have this pi over 4 angle, so we can pull up our sheet. You go back, say, I got a pi over 4 angle. This is the triangle I'm working with. So the side lengths, 1, 1, square root of 2. And now, how do we evaluate this? What this is going to say is that sine of 5 pi over 4 as the ratio should be 1 over square root of 2. But we need to be careful of these minus signs because we don't just have a triangle, we have a triangle in a reference frame, a coordinate frame. So the position of this triangle matters. So while I filled in the side lengths of 1, 1 square root of 2, relative to the coordinates, this 1 is in the negative x direction. So it's actually a negative 1. This 1 going downward, since it's going downward in the y direction, it's a negative 1 in the y direction. And so doing it that way, what do we see? See that the sine of now 5 pi over 4 is going to give us negative 1 over square root of 2. So we just need to add in a minus sign. Any questions on that? So the other thing we could have done for the plus and minus sign, and I'll start drawing this on our trig sheet, our reference sheet. We have this diagram. So the mnemonic device is all seniors take calculus. What does that mean? In the first quadrant, we have all trig functions are positive. In the second quadrant, only sine and the reciprocal, cosecant, are positive. T, quadrant 3, only tangent and cotangent are positive. And then, of course, in the fourth quadrant, only cosine and secant are positive. So this is another way to do it. Once you've drawn in the side lengths, once you've determined the reference angle and which triangle you should use, you fill in the side lengths, and then you could just say, well, we're in the third quadrant. And since we're in the third quadrant, tangent is positive. And only tangent is positive. So since we had a sine, we needed a minus sign. And so that minus sign essentially comes from the relative positioning of that. So let's use that now. Let's try to evaluate tangent of 7 pi over 6. Our first step, determine the reference angle. Big hint. If a fraction of pi is in lowest terms, the denominator determines the reference angle. Meaning 7 pi over 6 has a pi over 6 reference angle. So that's a big shortcut. If you want to use it, feel free. Let's talk it out though, figure out why this pi over 6 is our reference angle. Because step 2, we still need to determine the quadrant. So it's good practice to go through this. Let's expand our notions of pi and 2 pi. So what are the denominators that come up? It's either going to be pi over 2, or 2, I should say, 3, 4, or 6. I'm going to write out the same thing for 2 pi. So now what you can do, whenever you're given an angle, 7 pi over 6, the denominator is 6, fractions reduced, so the denominator is not going to change anymore. So since the denominator is 6, come over here to this little table we've drawn and go to the column where we've got 6's, and then now we want to ask 7 pi over 6, is that closer to 6 pi over 6 or 12 pi over 6? So closer to 6, and so what we want to do is write 7 pi over 6 is going to be 6 pi over 6, but we need one more, plus pi over 6. So, and again, that pi over 6 gives us this reference angle. If we were to draw it now, we have to go pi, 6 pi over 6, plus one more. So that's the extra pi over 6 there, that tiny angle. Sorry, that's hard to see. Still probably hard to see, but it's a pi over 6. And then, of course, halfway around, 6 pi over 6. And then we went one more to get 7 pi over 6. Pi over 6 now, this triangle is our reference angle, which determines the side ratios. 1, 2, square root of 3. And so what should we find? Tangent of 7 pi over 6 is opposite over adjacent. And moreover, the angle is in the third quadrant. And by our chart, third quadrant tangent is positive. So we can keep it as positive. The other way we could have done it, we didn't want to use this chart here. As we're filling in the signs, we could have just said, well, this negative square root of 3 is on the negative x-axis. The 1 should be negative as well because it's going downward. And as we would see, if I took the tangent in this case, I would get -1 divided by -√3, and those negatives would cancel, and we get the same thing. Any questions?
What if you had like 9 pi over 6 since it's in between?
Sorry, was someone saying something? Zach, did you have something?
Yeah, like if you had a like tangent of 9 pi over 6, since that's like in between 6 pi over 6 and 12 pi over 6, which one would you choose?
So what happens with 9 pi over 6 when you reduce it? It's actually
Oh, okay.
3 pi over 2. We'll talk about that one. Let's do, I think I want to do 2 more examples. So that's actually it's a quadrantal angle. And those we got to do a special case for. So we'll get to that question actually. Let's do one more with maybe a different denominator and a different quadrant. And then we'll do a quadrantal one so you guys can see how that one works as well. So let's evaluate cosecant of 5 pi over 3. If you want, we can keep our references handy. And then I don't want to redraw it out, but like pi equals 2 pi over 2, 3 pi over 3, 4 pi over 4. Always a good thing to keep handy as well if you want to add those to your sheets. And then that guy might be a good thing to throw in there. So our denominator is 3. Maybe we'll at least write those. So we've got 3 pi over 3 and 6 pi over 3. 5 pi over 3, which one's it closer to? So closest to 6, right? 6 pi over 3. So how do we write it? 5 pi over 3. And again, we could think ahead. Denominator's 3. It's a reduced fraction. So the reference angle is 3. And how do we get that? Well, 5 pi over 3, it's close to 6 pi over 3, but it's actually less than 6 pi over 3. So we have to go 6 pi over 3 and then back 1. So minus pi over 3. And so how that works, drawing it, you can think of it like we go all the way around the circle, 2 pi or 6 pi over 3, and then we just go back now pi over 3. So our angle is something like that, maybe even steeper than that. So we would go all the way around the circle and then back pi over 3. Always draw this side perpendicular to the x-axis. So we've got pi over 3. Pi over 3 is the bigger angle. So short side's 1, long side's 2, other side is square root of 3. And then if we want, we can fill in the positives and negatives. That's in the positive x, so that'll stay positive. But that square root of 3 is in the negative y direction. So negative square root of 3. And now all we got to do is evaluate. So cosecant of 5 pi over 3. Got to remember what cosecant is. So cosecant is associated with sine, and it's the opposite of sine, reciprocal of sine. So sine is opposite over hypotenuse. We just want to flip them and do hypotenuse over the opposite. So you can shuffle that minus sign around. You can leave it out front, however you want. I should mention the other thing you might see is rationalizing the denominators. So sometimes the answers could be written where we multiply numerator and denominator by square root of 3 over itself. And so we will get negative 2 square root of 3 over 3. I'm fine with these answers. College math, we don't really care about square roots in the denominator. Any questions? Hopefully
I'm still trying to figure out why root 3 coincides with the side with a 90-degree angle. I don't know if it's just because it's not drawn to scale like that.
What do you mean in a 90-degree angle? So this triangle here?
No, when you were doing wait a minute. Okay, never mind.
Okay.
I guess I was thinking root 3 was larger than 2, and so I thought you would switch that, but never mind.
Yeah. See, it's easy to confuse. Remember, I mean, 3 is bigger than 2, but as soon as we take a square root, it's like 1 point, I don't know, maybe 1.5-ish. Maybe a little bigger, but less than 2, yeah. Okay, so let's do one more example, and let's see how to do these quadrantal angles. So as the question was brought up before, well, what happens if it's halfway in between? So evaluate, let's say the 6th trig, let's do all of them. On 3 pi over 2. So first step, always make sure the fraction is reduced. If someone else is like, well, what happens if it's 9 pi over 6? Because it's halfway in between. But if you reduce that, then you realize you're 3 pi over 2. And so we're still going to work with the denominator of 2, and actually we're still going to run into that same problem. It is halfway in between. So I'll show you how to work this out. Because, so what do we have? We have pi is equal to 2 pi over 2. 2 pi is 4 pi over 2. So 3 is right in the middle, and it actually means that it doesn't matter which one we want to start with, or however we want to go about figuring this out, or whatever kind of diagram we want to draw. Of course, as long as it's in the correct position, we could either say that 3 pi over 2 means I have to go halfway around the circle, and then another pi over 2. Or we could have it 3 pi over 2 is go all the way around the circle and then go back pi over 2. These ones, it doesn't quite matter. So our reference angle is still pi over 2. But these ones are weird. So how do you draw it? Where's the angle? Well, if I go halfway around and then another pi over 2, we are here. Conversely, I could have gone all the way around and back pi over 2. So that's our angle. It's formed by these two sides, the positive x and the negative y axes. And how do we evaluate the 6 trig functions on this? What I recommend doing, and what I like to do, is to essentially just take this bottom one and extend it over a little bit. So I draw what I call a degenerate triangle. And so if we were to draw this maybe a slightly different, let's try to draw it bigger. That's really, you have a triangle like this. So always remember that this side should have been perpendicular to the x-axis. But because this side here, so if this was our clock hand swinging around, it should be lined up vertically. And what's going to happen with that? If the clock hand moves, it's going to smash this side together. meaning that this side, even though I gave it a width, there's no actual width to it. It should be 0. And that means if this side length is 0, both the hypotenuse and the other side are the same length, because this vertical side, as I smash it over, essentially overlaps the hypotenuse. So they essentially become the same. So I don't know if you guys can see that. That one's a little... So both sides I label as 1. The key thing is understanding which side should be 0. So just make sure you're drawing your one side always straight down to the x-axis and not like over or anything like that. And so my angle, your pi/4 is actually, it's this angle here. And it is a 90-degree angle. So you can label it as a 90-degree if you want. This triangle shouldn't exist, right? One side length is 0. We're just drawing it as if it had that positive side length, just to apply some labels, because that helps us compute the trig values. So sine of 3pi/2. So actually, let's keep track of the positives and negatives as well. 3pi/2, because it's a quadrantal angle, it doesn't lie in either the third or fourth quadrant. So it can be kind of confusing as to what's positive and what's negative. And you got to just understand how to think through it. So the hypotenuse, always positive. Hypotenuse is always, always, always positive. And so this -1, we think of this side as going now negative in the y direction. So this should be a -1. And now when I want to compute sine of this angle, we're going to get the opposite over the hypotenuse. So -1/1, or just -1. Always be careful, right? It is this side here. Always the angle that is in the corner of the vertex, not this other side. So we've got sine, cosine. Will give me the adjacent side over the hypotenuse. Tangent is going to be the opposite over adjacent. What happens with this guy? Cannot divide by 0. Yeah, so undefined. And then all we have to do is do the reciprocal ones now as well. So let's go through those. Cosecant, secant, cotangent.
Oh shit, secant's undefined.
Yeah, so a few of these will be undefined. Be careful though of since tangent was undefined, when we take a reciprocal, by the magic of infinity really, we actually get a definite value for that. So sine, cosecant is just going to be 1 divided by this, or we could think of it as the hypotenuse over the adjacent. Of course, we get the same thing. 1 divided by -1, still -1. Secant, though, if I flip those two, 1 divided by 0 gives us undefined. Likewise, of course, that is the hypotenuse divided by the adjacent. Cotangent, though, what's going to happen? If I do cotangent, the adjacent over the opposite, get 0 over -1, and now it's 0. So that is actually defined. I guess we'll do a bit more of that in calculus. Undefined, we do want to think more of as like infinity. And so if this were like 1 divided by infinity, or 1 divided by 0 is infinity, but then 1 divided by infinity, 1 divided by an undefined number actually kind of gives us 0 in some sense. Any questions on that?